Okay, so drawing the parallelepiped, remember where this parallelepiped comes from. Comes from this picture. We see how this parallelepiped is just a prism that goes up and intersects the paraboloid at these 4 points. That probably doesn't look like this. Okay, I could have made it more precise, but it's just representative, okay? So here it is, and of course we have this point here, as we saw previously. So I'm just pulling this picture out, and here it is again. Put a little bigger, so I have plenty of room to label it, and do other things. Okay, so we have this point, and of course this point now. And we talked about where this point comes from. Think what the coordinates of this point would be if you haven't already. In any case, this point is well, this point down here, here's x naught, y naught, here's a delta y, and here's a delta x. So this point is x naught plus delta x, y naught plus delta y is 0. I'll actually label that one. So this point up here, being directly above this one, has the same x and y coordinates, but now you have the z coordinate, and z equals f of x, y. And that equals I shouldn't have labeled this because I need a little more room here than I got. And there it is. And then this point should be pretty obvious by now is think before you write. X naught plus delta x, y naught, f of x naught plus delta x, y naught, and of course then that equals x naught plus delta x, y naught, x naught plus delta x quantity squared plus y naught squared. And that's this point. Okay? So tell me, write down the expression for the slope of this segment. So I'm going to just do a quick schematic of the picture here. And the picture's not going to look the same if I draw it again, but we understand what it means. It looks reasonably the same. what's the expression for the slope of this segment, and this expression for the slope of this segment.